Good day to each and everyone. I am Erica Sevilla Gracia from Bachelor of Secondary Education, major in Biological Science, and welcome to our discussion for today, Mathematics in Modern World. And in this video, I am going to discuss the arithmetic operations modulo n. So before we start our discussion, let's define what is modular arithmetic first. So modular arithmetic is a system of arithmetic for integers which considers the remainder. In modular arithmetic, numbers wrap around upon reaching a given fixed quantity, or this given quantity is known as the modulus, to leave a remainder. An intuitive usage of modular arithmetic is with a 12-hour clock. If it is 10 o'clock now, then in 5 hours, the clock will show 3 o'clock instead of 15 o'clock. 3 is the remainder of 15 with a modulus of 12. In modular arithmetic, the numbers we are dealing with are just integers, and there are 3 operations of modulo n. So what are those 3 operations? The 3 operations of modulo n are the addition, the subtraction, and the multiplication. So why do we study arithmetic modulo n? And why is it important, or how is it important in our daily activities? So the arithmetic modulo n is basically an arithmetic of remainder. So it is one way of determining the remainder of a division, and it also helps us to determine a leap year and the day of our birthday without looking to the calendar, and it also helps us determine the time. Now, let us have the arithmetic operation modulo n. So to solve an arithmetic operation, perform its operation and then divide by the modulus n. Note that the remainder is the answer. The result of an arithmetic operation mod n is always a whole number less than n. So let's start with our examples. Let's start with addition modulo n. Our example number 1 is we are going to evaluate 23 plus 38 mod 12. First of all, we need to simply follow the operation and add 23 and 38, which is equal to 61. Then, divide it by the modulus 12. So we have 5 multiplied to 12 is 60, which leaves a remainder of 1. And that remainder automatically become our answer. Let's have our second example. We need to find the sum of 35 and 80. Similarly, we will get the sum of 35 and 80, which is 115. Dividing this by the modulus 11, we will get the remainder of 5. In symbol 115 mod 11 is equal to 5. Our third example for the addition modulo n is we are going to evaluate 4 plus 7 mod 4. Now, we are going to add 4 plus 7, which is equal to 11. Then divide it by the modulus 4. So we have 2 multiplied to 4 is 8, which leaves a remainder of 3. And that remainder automatically become our answer. Now, let's proceed to the next operation of modulo n, which is the subtraction. So just like the addition modulo n, we just have to subtract the variables and divide it by the modulus, and whatever the remainder is, that will be our final answer. So let's have our example number 4. We need to evaluate 33 minus 16 mod 6. So 33 minus 16 is equals to 17 divided by the modulus, which is 6. So, 2 multiplied to 6 is 12, which gave us a remainder of 5. And that remainder automatically becomes our answer. Therefore, 17 mod 6 is equals to 5. Now, let us move on to our example number 5 under the subtraction modulo n. So, 14 minus 12 mod 5. So, 14 decreased by 27 is going to give us negative 13 mod 5. So, just like what I've told you earlier, the result of the arithmetic operation modulo n is always a whole number less than n. So what we are going to do if we have negative answer? We are going to turn it into a positive number by adding the multiples of n until we get the smallest positive number less than n. So let us add this. Negative 13 plus our modulus, which is 5, we're gonna get negative 8, which is not a positive number yet. So, add 5 again. Negative 8 plus 5 is equals to negative 3. Since it's not a positive number yet, we're going to add 5 again. Negative 3 plus 5 is equals to 2. Since 2 is a positive number, therefore, 2 is automatically becomes our final answer. The last operation of arithmetic modulo n is multiplication. Now, let's have our example number 6 under multiplication modulo n. Let's try to evaluate 15 times 23 mod 11. Just like in the previous operations, the first thing we need to do is to perform the operation and multiply by 15 to 23, then we divide our answer, which is 345 with a fixed modulus. So 31 multiplied to 11 is 341, which leave us a remainder of 4. Therefore, the remainder 4 is our answer in this example. For our example number 7, we have 5 multiplied by 8 mod 7. So 5 multiplied by 8 is 40, and then divided by the modulus 7, the remainder is our answer, which is the 5. Now that we are done discussing the arithmetic operation modulo n, let's try another examples in calculating times to test our knowledge. So, this regarding AM or PM. If it is 5 o'clock now, what time was it 57 hours ago? Here, our keywords is hours ago, which means to subtract time. So, our starting time is 5 o'clock minus 57, and the value of our modulo is 12 since we are referring to a time. Next, we have to apply the subtraction of modulo. 5 minus 57 is negative 52 modulo 12. Hence, we can't divide the answer to the modulo since the answer we have is negative number. So just like the method I have discussed previously, we have to add up multiples of 12 until we get the smallest positive number less than 12. So, negative 52 plus 12 is negative 40. Raised by 12 again is equal to negative 28. Added by 12 again is equal to negative 16. Plus 12, which is negative 4. Plus 12 again is equal to positive 8. Thus, 5 minus 57 mod 12 is equals to 8. Therefore, if it is 5 o'clock now, 57 hours ago was 8 o'clock. So next example number 9. Let's consider a clock with 8 hours. if you start a class at 7 o'clock and it runs for 2 hours, what time will it say on the clock at the end? First thing we're gonna do is to add 7 and 2, which is 9. Dividing this by the modulus 8, we will get the remainder of 1. Therefore, if you start a class at 7 o'clock and it runs for 2 hours, the time on the clock at the end says 1 o'clock. So our last example, which is the example number 10, is a day of the week. If today is Friday, what day of the week will be 46 days from now? Here, our keywords is 46 days from now. So it means we have to use addition, and our starting day is Friday. That is denoted by 5. And then, add the 46 days mod 7 since we are referring to the day of the week. So applying the addition of modulo n, we have 51 mod 7, and using the arithmetic operation, we have to divide 51 by 7. So 7 multiplied to 7 is 49, which leave us a remainder of 2. So what is our second day of the week? Since 0 is Sunday, it means 2 is Tuesday. Therefore, we have 51 mod 7 is equals to 2, which corresponds to Tuesday. So that concludes the arithmetic operation modulo n. I hope that you learned on my discussion on how to use it, and I hope you can also use it in the future. Thank you so much for watching and stay safe everyone. God bless us all. Bye!